Good morning, everyone. How you doing? Or afternoon or evening, depending on where you are in the world. My name is Chris MacBain. I'm an industry process consultant here with Dassault. You may have been expecting to see the cheery face of Mike Buckley. He is actually out in the field today and asked me to fill in for him, and I'm more than happy to do so. I'm so excited to be here. Our guest today is Craig Serkanic. He and I go way back. Hi, Craig. How you doing, buddy?
Good, good. How are you, Chris?
Good. I'm so happy. I'm happy to be here. I'm happy to be talking to you. For those of you out there, you know, Craig is an expert at post processors. Him and I go back. How long has it been, Craig? Probably over 20 years, probably.
Yeah, it's over 20.
Close,
yeah.
Right? So
yeah.
I wanted Craig on because out of all the things we do in camp, right, making pocket slots, 5-axis, 5-axis, mill turn simultaneous, the one thing all of those have in common is the post processor, right? And it's something that we all know, and it's just kind of sometimes annoying, and oh, you know, I have to do this. So what I wanted to do is kind of start the conversation with Craig and with everybody on the line here about post processors. I wanted to talk about what they are, good ones, bad ones, all kinds of things, and kind of get your feedback. So throughout this, I'm going to be asking to put stuff in the chat. So please, everyone out there, just throw something in the chat. We'd love to hear from you. Craig, so we go way back. I know all about you. So how did you get into or fall into or get pushed over the edge into customizing post processors?
Yeah, that's a great question. So my history starts in the shop, right? Just cranking handles or turning handles, running lathes, running mills, sliding into the CNC side of things, and then advancing into those areas. And I ended up reaching out at one point throughout my career, and I ended up getting a position as an AE for a reseller of CAM software. And I quickly, in there, I was in the role of selling, supporting, mostly technical. I'm a very technical guy. I like sales, but I'm just not that. I'm not geared towards sales. I'm geared toward technical stuff. So
that's because we're shop guys, Craig. We're not geared towards sales.
Yeah, you're right. It's there's just difficult areas to bridge. You'd always say, you know, that was the fallback. I'll just, you know, not taking anything away from sales guys. Trust me, I know you guys work hard, but that was always the thing. Like, I can jump into a sales position if I need to, right?
Right.
But no, I can't do that. Not me. I would quickly fail. So anyway, as I was as an AE, I quickly realized that there were some areas that were lacking, right? Like the software can do certain things, but there was more that was needed. It was always a little something. Every time you go to a customer, there's a little something extra they need out of the software. Just doesn't quite do this, or doesn't quite do that, or just doesn't function. And so that area quickly became evident that there was a need. So what had happened was I kind of, in amongst the time of me doing technical support and training and a little bit of selling, I started picking up the posts and dealing with that. And that's pretty much how I fell into it. Just kind of trying to get things going.
So let me ask you something. A couple things that you talked about in there. So you talked about kind of falling into making these post processors. So how, when you were an application engineer, how do you determine whether it's the software or the post processor?
Yeah, that's a good question.
I imagine that a lot of people I've seen in the field, right? Salespeople, depending on what's more beneficial for them, blame the post or blame the software. Oh, the software just can't do that, right? So how do you determine, as an application engineer, which one it is?
Right. So first of all, it's always the post. Always, like hands down, always the post. You will never get away from it. The post writer is always to blame. But once you run into an issue, what that issue may be depends upon, you know, who's sending it in, right? A lot of times I got to know that my customers quite well. I would reach out and talk to them and you know, pick up the phone rather than email. Not saying that you can't get things done via email, but it was just easier to talk because there's always stuff that gets lost within an email. So I would always, you know, that was my thing, is I would always pick up and call and try and understand where that customer is coming from, because my position is totally different than the customer's position. So once I kind of understand what they're after and what they're looking for, then you can evaluate whether or not the software is to blame, if you will, or something's lacking there, or it's actually something to do with the post. So there's a lot kind of, that's a very tricky question. And there's a lot of tricky questions here, right? There's a couple ways you can go. And maybe that's why the post side of things is one of those areas where people just kind of stay away or push away.
So let me ask you about that too. So we talk about that post area and people staying away. We never had a custom post in the shops that I worked at, right? We were hand coding, and we'll talk about that. We'll talk about that in a second. You know what? Actually, before we get on that, people on this, put a +1 in the chat if you're actually editing by hand the posts as you do it. Because I'm just really curious, because when I was in the shop, custom posts were, I mean, that was the unicorn. Like, you worked in a great shop if you had a custom post, right?
Yeah.
And one of the reasons when I asked my boss, as everything, it's money, right? So why are posts so expensive?
Yeah, that's a great question. And that question actually has to do with kind of where you're going, what you're purchasing, who you're working with, right? The post, if you really look at posts and their expense, it basically comes down to time. You know, you're paying for that person, whether it be me, whether it be Joe down the street, or you know, whoever around the world, you're paying for that person's time. And the trick is it's just like coding. If you've ever been around coding or kind of dug into coding a little bit, you quickly realize that there's bugs within the code, and you have to find those, and those can take time. You know, I've been around where you know, where guys have explained something to me and I took it in as such, thinking I understood it completely. And then I get into it, and I'm into it about, you know, a half a day, and I'm like, I'm just not seeing it. I don't get it. And I realized that wasn't exactly what he was talking about. And it led me down a different path. So, you know, you kind of you're paying for that guy's time, and to put a time or a monetary value on that, it's very difficult. It's very difficult for the company, and it's very difficult for the guy who's writing the post, right? So that's really all it is. Like, everybody goes, oh, I want it for free, I should get it for free. And to some degree, there's stuff that's built in for free, right? The companies that are selling posts and CAM systems try to build and pad a little bit and make that go. But when you really get into it, and you're starting to deal with really custom stuff, then that's where the price changes. And I mean, let's face it, nobody really understands the posting area, right? So how do you put a value on that? How do you put time? How do you put money on that? And it becomes, it's kind of tricky in that regard.
Yeah. So speaking of tricky, let's talk about posts and tricky posts, right? And expensive posts and things like that. I wanted to talk about that for a couple seconds. So obviously there are more complex machines than, you know, every machine doesn't take the same post, although the Cartesian coordinate system doesn't change, right? And it has to do with how it digests those, right? So that being said, there are definitely more complex post processors, right? So one thing I wanted to do is I wanted to just explain a little about what a post processor is, because a lot of people have questions like, what exactly is a post processor? So let me give you my take, Craig, and then correct me if I'm wrong, and then give me your take, because I've heard this a couple times. Sure. So what I feel, or the way that a post processor works, is it's like a driver or for a printer, right? So you have a CNC machine, and think of your CNC machine as your handy dandy little printer that's on your desk, right? Well, when you hit print on your computer, right, your computer has to take that little image or cartoon on your screen and push it, and then do it in a language that the printer will understand. And that's how you get a nice little document printed out. So that's what a post processor is. And just like each printer needs its own driver, each CNC machine needs its own post processor. So Craig, would you say that I heard that years ago? I mean, would you say that that's a good description?
Yeah.
And what would be your description of it?
Yeah, no, I like that description. Actually, that's a very good layman terms way of explaining that, right? You know, the post processors obviously take, you know, the items that are coming from the CAM system and put it to the machine, right? Put it to a language that the machine can understand. And as you stated, that machine language is different, right? The structure is different. You have many variations on that. And so you have to match that up. Positioning of certain G code is mandatory in certain situations, and you've got to do that for each and every control that you're working with. So so there is that, you know, that customization that's always happening per control. But the root, if you really look at the root of it, the base core of it is still pretty much the same, right? I mean, if I'm doing a line move, I'm doing a line move. How that comes out is dependent upon the control, but you're still going through a line move area, right? Or an arc or what have you. So, you know, the key, what I quickly found in my career was that if I had the core of my posts working properly, which is hard to do, especially when you're managing a lot of customers. If your core post is good, then the rest of it kind of falls into place, right? The edits and the changes, they're just more cosmetic than everything else. But what generally happens is you can have people that don't understand exactly what's happening. So you make a change in one spot, but it affects 5 other places. And they didn't realize it, right? Oh, I made that change, or I didn't test against it. Or, you know, in the advent of time, what do we short? We short testing, right? Or we short the follow through, because guess what? The customer isn't going to pay for that, but we need to understand where those changes affect throughout the entire code. And so there's a balance, right? There's always a balance. It's, you know, what's the customer going to pay? What's the company going to let you do? Can you go and rebuild this? Can you make the core of the post processor better so that it supports more? You know, one of the things that I would do inside there is I would create things that are just standard, you know, so like coolants, all standard. M codes that come out for those, or codes that come out to produce the coolant on the floor, those change, right? But as long as the core was functioning, then most of it was cosmetic. Now, just because it's cosmetic doesn't mean it's a oh, I'll just flip a switch and I'm good to go, or it's a 2-second job. Cosmetic changes can take they can take days. They can take just as long as the complex solving of problems throughout the post. So so yeah, I mean, you kind of you're continually balancing those languages back and forth.
Yeah. So you said something. There's 2 things I really want to hit, and one you talked about cosmetic changes, right? And I've written a very small amount of post processors in my career, but the one thing I learned was you never ask, why would you want to do that? Right.
Yeah,
especially
exactly.
with the cosmetic things. Because when I started, I had customers saying, okay, I want an empty line before and after each tool change, so I can see it when I'm going through the code, or after every, I don't know, coolant on, coolant off, I want something else to happen, just so they can see it correctly. You know, what are some of the strangest requests you've gotten just for the cosmetic? Like, I want to see the code. What are some of the craziest requests?
Yeah. I've had some crazy ones. I mean, I've had some core crazy ones, right? So I'll give you an example of one that was pertinent. It was something we needed to have, right? And it's common, like Haas machines. So we'll throw Haas out there. There are, you know, they're known everywhere. You can get all their documentation online. And Haas, when you're using a Haas mill, you use through a coolant spindle. The coolant through the spindle, which is an M88 and an M89. What happens is if the M88 is called after the spindle gets turned on, the spindle shuts down automatically. and the coolant then gets called, and then you have to recall the spindle again, right? So what'll happen is, if you're not paying attention, or if you're not writing the code correctly, just for that through coolant, it has to come on before the spindle gets turned on. There's some lubrication thing that goes on there. And again, I'm not the guy who built the machine, so I believe the coolant lubricates that spindle as well. It does a double duty when it's doing that. But so what had happened was, I had a customer, I've been writing Haas posts for a while, and they had through coolant, and nobody ever told me that. Nobody said anything. And as a post writer, I'm like, cruising along, everything's great. And so a guy goes, hey, he goes, I need this. And I'm like, what? Can you explain why? What's going on? He goes, yeah. He goes, it's the weirdest thing. He goes, I don't really understand it either. He goes, but when I use through the spindle coolant, M88, if it's not before the spindle on, then the spindle shuts down, and then I have to reissue a spindle code. I'm like, okay, so no problem. Let me work on that. So you got to go in, you got to, do this, do that, check for things and whatever, and then fire it. And so I got my posts working so that if through the spindle coolant was being called, M88 would come out prior to the spindle getting turned on, and life was good. Everybody was great with that. And some customers realized it. Some customers had no idea it was even happening, right? And Haas, being Haas, they kind of catch things for you, right? So they go, oh, your spindle's not on. Guess what? You're getting ready to cut. Let's turn that on, and they'll do it for you. So some of it takes some of that out of the post, but it's just that kind of a thing where you look at it and you go, wow, that's a crazy request. But the reality is, it's not crazy. It's actually fundamentally important for the proper operation of the machine, right? So that's one. You get that kind of a core request that you go, that's kind of loony. But when you really dig into it and understand why it's being asked and what's going on, just like you said, never ask the question, why would you do, or, why would you want to do that? There is generally a reason why you're trying to get something done, or that customer.
No, you're absolutely right, Craig. You're absolutely right. And so there, I guess the thing there is, like, there's no dumb requests, right? There's a reason people are asking.
Absolutely.
And this is an amazing lead in into the other thing that I was really thinking as you were talking. The overarching theme here is communication. Like, that's the key to getting a good post processor, right? Is to being able to communicate with whoever is writing your post processor, right?
True.
And we'll get to that in a second. Like, who writes these things? Like, how do I get one? Like, we'll get to that in a little bit. So communication. What kind of information should a user have before they request their post processor? Let's say they've come to the realization they're not getting the most out of their machine, and I need a better post processor.
Right.
What information should they have at hand as they reach out to their post writer, their reseller, their VAR, whatever it is?
So that question is a tricky question, right? Because what you're asking is, it really depends on, everything, actually. So it depends on the user. It depends on the post writer. It depends a lot on the understanding of the machine. So I've had customers go, hey, this thing's not doing this correctly. Mill turn gets real complex, right? So when you're working on the front face of a part in mill turn, there's many, many different codes to get things done. You have polar, you have free versus fixed. You have all kinds of different, you have all kinds of different functions that are available to you on that machine. And everybody has their slice or understanding of what those are supposed to look like. And so, for instance, if you're doing polar on the front face of a mill turn, you're going to get negative X and negative Y moves. That's just going to happen, because what happens is, behind the scenes, the control takes those coordinates, trigs those out, and figures out where on the front of that circle, in that 360-degree circle, that tool needs to lie. And there's math that's being done behind the scenes. But I've had customers call me up and go, hey, Craig, this is producing a negative Y and a negative X. It should not. And I'm like, well, wait a minute, hang on. Let's see, what are we working with here first, right? Are we, are you in polar, right? First question, are you in polar? I don't know. okay, is this G code present? Is that G code present? And then you can kind of deduce where and what needs to be looked at to kind of move forward. So yeah, I mean, those kinds of things, the understanding, like to just, you know, flat out say, I need this, I need that, and this will get your answer for you or get your post corrected properly, is probably a misnomer, right? That's something that's not possible. There's always got to be some back and forth. And it's frustrating because you're dealing with time, right? Everybody needs to crank parts out. Everybody expects the post and the software to run perfectly. The reality is that just doesn't happen all the time, right? And there's got to be some communication back and forth. But again, you're dealing with, you know, time, and time is money always in our industry. So it's tricky. It's real tricky. Yeah.
So you talked about that a little bit, excuse me, about time, right? So there's in first time, all this other crazy things you put in your posts, right? Yeah.
Right. Yeah.
So
yeah.
Let me ask you something. And you also talked about math and triggering stuff out. There's a concept in machining in general, but in post, it's called singularity, right? Could you explain what singularity is and why it's so bad?
Well, so I don't know if I can completely answer that one 100%, right? You know, when we talk about, you know, you talk about time, just time in general, we talk about, you know, you know, there's obviously different feed rates and things like that, as you mentioned. And I might deviate a little bit from that question. So
that's fine. Go ahead.
Yeah,
no, that's fine. Yeah, you go.
We talk about that. So like you said, you know, we just, as we get into the writing of that post, everybody says, you know, this is how I need it to be. But, you know, there's always a little give and take. There's always a little learning from everybody, you know, and same thing with me, even as a post writer for, you know, almost 20 years of in that language, I was learning all the time, just new things and constantly picking up on different ways customers were going about things and what they needed specifically. And, you know, you get into inverse time, right? Inverse time started to, I mean, it's been around for a long, long time, but people didn't use it, right? And they didn't know what to do with it. So when you said, hey, I'm doing inverse time, but you look at it and you go, well, wait a minute, you know, are we on mill turn? Well, yeah, we're on a mill turn. Okay, is it degrees per minute or is it inverse time? Or is it just straight feed rate, right? Those are the questions that start to arise, and nobody can really, I shouldn't say nobody can answer them, but you never really get the right answer or the direct answer. You get an interpretation of what they think it should be. Some customers are spot on. They've gone through the book, they've done, you know, their homework, and they've looked at everything inside and out, and they know exactly where it's supposed to be. But others are just trying to get parts out the door. You know, they're just, or hey, I machine part-time. I'm an engineer, you know, 90% of the time, 10% I'm trying to get this part out the door. What is happening?
Could you explain the difference between degrees per minute, inverse time, or just straight feed rate?
Yeah, sure. So straight feed rate is our inches per minute, right? It's pretty,
or revolutions,
or revolutions per minute, or, you know, what you would have there. And then you get into degrees per minute. So when you're on a mill turn, if the C is moving, the mill turn absorbs. You don't have to have any special G code for it. It just kind of absorbs the calculation, but it must be in degrees per minute. Anytime the C axis is moving, it must be in degrees per minute. And you can look at it like everybody goes, oh my gosh, my feed rate is 1,000 inches per minute, degrees per minute. So think about it. I do 360 degrees. Let's just do a simple 360 degrees per minute. So if I have that's one revolution in a minute. That's not very fast at all, right? So what happens is your post needs to take that linear feed rate and calculate it into an angular feed rate. And that's what the machine accepts when C is present, right? If it's just X and Y, it should be linear, always. X, Y, and Z, always linear. That's a linear. But when C is present, you must produce a degree per minute call to be able to drive that C axis, right? All the other axes fall into place, and everything works off in that regard. So that's kind of, excuse me, that's kind of what's happening. And that falls under the inches per minute or meters per minute, millimeters per minute, G94 G code. And then you get into inverse time, excuse me. And inverse time is actually, and it's been a little while since I've done it, but everybody has each manufacturer has a little bit different way of doing it. Some of them do them off of encoders. So it's the time the encoder, it's the ticks on the encoder. That was one way one of them did it. But it's basically, it's not the feed rate per se, it's the actual time it takes to get there, right? So basically what you do is you have like a 5-axis machine, and you call inverse time G93, and you're saying, look, I need every axis to be there in this amount of time. And that's how everything syncs together, right? So depending on, my dog's getting up here, sorry. Every machine's a little bit different, but that's kind of how that works. And it's basically done off of vectoring, and it's a vector calculation that takes place.
Yeah, that makes a lot of sense. That really does.
And it's tricky because the numbers are big, right? So when you get into inverse time, you're looking at thousands or 10,000, inverse times, so, and then when you get in degrees, it's the same thing. It's a big number. So they get confused very quickly.
So this is something. So I also want this webinar to cover the basics and the more advanced stuff. So the basics is, we talk about M codes and G codes just to make sure that we're all kind of on the same page. The G codes are movements, right? Where you're going to move G1, G2, straight line moves, or G1 straight line move, G2, G3 curves, things like that. Yeah. M codes are utilities, right? They call up the special things your machine can do. Turn the tool turn around, turn the coolant on, it's these little solenoids, right? Start the pizza cooker on top of the machine, whatever it is. Those are the M codes that go into this. That's one of the things. The other thing I wanted to talk about a little bit too, is you just touched on it a little bit. And those of us that have been in the machining, we know this, but again, I just want to make sure that we're all on the same page. One of the reasons that you use degrees per minute and not inches per minute in turning is as you come down on a part, as it rotates, if you do inches per minute, you're really going to increase the spindle speed of that lathe. If you do degrees per minute, that rotational time is going to be the same no matter what the diameter you're turning is. So that's going to be that's a really important point too.
There's a little misconception there. So,
oh, please, go.
That's okay. I think you're thinking of surface footage per minute, SFM versus RPM. And that's actually different in turning. So the degrees per minute and the inches per minute, we're talking about milling and the actual movement of the tool, like an end mill across a certain space. And I think what you're referring to is the surface footage, where you call up, let's just say it's 400 surface feet per minute. And what happens is and you say, okay, I'm moving my tool at 2,000 inches a minute, right? Whatever. And what happens is when you go from a large diameter down to a small diameter, your RPM consistently increases and increases and increases, keeping an even chip load as you get to the center, right? And that is surface foot. And again, I could be wrong here, but that's surface foot. Where degrees per minute is different. You're dealing with, like I said, linear versus angular, and that. So basically, anytime and this is in milling, you'd never use degrees per minute in turning. It's only in milling, right? So in milling, we're moving X, Y, and Z, for instance, or we're moving X and Y or X and Z. That's all linear, inches per minute or degrees per minute, right? So degrees per minute is that thousandths or the chip load. With that, wait, hang on, I'm getting confused. Sorry. So
that's my fault, Craig. I confused you because you're absolutely right. We were talking. I was referring to surface feet per minute, right? Because the surface feet that go around that right?
Right.
It decreases as the diameter decreases. So you're absolutely right. Thank you.
Yeah, the RPM increases. Yeah.
So
thank you
so much.
Kind of, you take those two out. Like, those still work the same. Degrees per or surface foot versus RPM. Those work the same. G95, which is kind of standard. Again, if you have a different machine, you could be a little different. But G95, G96, G97, those are kind of not 95, 97, 96 RPM versus surface footage. And then degrees per minute stays in the 94, which is your feed rate, but you're actually calculating, the degrees per minute that you would rotate around. So yeah, it's a little different. It doesn't necessarily keep the chip load the same as you get closer, right? It's just a linear movement.
That absolutely makes sense. Yeah, thank you. Thanks for that explanation.
No, it's interesting that you even mentioned that happens just like that. That happens a lot, and like I said, I can confuse myself. Like, I go, okay, wait a minute. We're talking about all kinds of different things here. And of course, as a post writer, you always want to be right. You always want to drive in the right direction. Again, we're talking about time. We're talking about money. We're talking about getting parts out the door. As I slouch down, back up again. Sorry. So we're always talking about that, right? And it's important. And generally, the person that is trying to get their post corrected, they're in the same boat. They're like, I don't know why this is not working. I need your help. I'm reaching out to you,
So that's a really good point too, is, anybody on the line that's watching us or even watching us in recording, we don't expect you to be the expert on your machine, right? We're not expecting you to say, well, I don't know what I need, right? I can't call up my post writer because I'm not, all I know is that the machine's not doing XYZ. I don't even know it's supposed to. I'm not sure. Reach out and talk to the post writer. They'll let you know. They see this stuff every day. They know your machine, maybe not the exact model, but they know the manufacturer and they know what your machine's supposed to do. So it's really important, if you think you're not getting the most out of your machine, to call, reach out, communicate. That's a big thing with your post writer. So we're talking, you really educated me. Thank you on that, Craig. And let's talk about learning for a second. So I get a new machine. We talk about people getting new machines and not knowing. I get a brand new machine. And when I mean new, it's not an Akuma, it's not a Haas, it's not one of the big ones, right? It's something that somebody made in their garage. I bought it off of, I don't know, Temu or something. I don't know. I get it in the mail. How do you learn what code it's using? Or even if, let's say, we'll use, say, an Akuma comes out. Akuma is pretty advanced G code.
Sure.
A new Akuma comes out. How do you find out how that code is supposed to look?
Yeah, that's a good question. So you have two categories of code, right? You have conversational code, and then you have ISO G&M code. And those two things need to be determined first off, right? Generally speaking, conversational code is code that is written basically standing in front of the machine. You're typing in, hey, I need a pocket, I need to go this deep. And then it kind of produces some code from human language into G code, and it makes the machine run. That code generally can't be edited. There are instances where you can write conversational code coming out of your CAM system, but it's few and far between. It's not the de facto, if you will, and for a couple reasons. One being that language is not written down anywhere. Like, I've had customers come to me and go, I need this in conversational, and we would reach out to the manufacturer and we're like, hey, we're talking to the main guy and we're like, we need this. And they're like, we don't have anything like that, like any documentation on how this is done. And you're stuck. At that point, you're literally just stuck. You cannot determine what, some funky word translates to G code, or what that looks like in G code. You have no idea. So conversational is generally not one of the languages that you're going to be getting from a CAM system. Not to say you can't do it. It's just not general. It doesn't happen often. Then you go to the ISO stuff, right? So once you determine, whether you're conversational or ISO, and generally 99% of the time you're ISO, you then need to dig into the manual, right? There's just no way around it. Like, I can't tell you how many manuals I've read or how many manuals I even have, because you're constantly learning, you're constantly going through this stuff and over and over and over again. And you read one manual and on one machine, X does this, or maybe X is probably not good letter to use, but let's call it, you know, Q. Q does this, but on this machine, Q does something completely different. And, you know, you've got to keep those separated and you know, segregated from one another, if you will.
Sure.
So again, that's kind of where you get into the core of your post. Back to the beginning, does the core of your post function properly? If the core functions properly, we're dealing with cosmetics at that point, right? So cosmetics is a little easier to handle. You can kind of get those done pretty quickly depending on what's going on. But if the core is not functioning, or it needs to function differently, in the scenario that I used earlier with through spindle coolant, right, on a Haas, where that had to come before the spindle on call, that's a function that's not cosmetic. That's core. You have to change some logic inside the post so that it does things differently, and gets the result that you're looking for. So that's more core. So most of the time, new machines coming out base their, and again, and this is very general, you know, it's not something to go to your machine salesman and go, hey, Craig said this. No, but it, you know, most machines are building off the predecessor machine, right? So they're building from what they already know and what they've proven. And a lot of times, you know, like you said, Okuma. So you take Okuma, for instance, you know, they had OSP 100, and then they went to an OSP 200. OSP 200 was a complete revamp on the OSP 100 series. 100 did its job, but the 200 excelled far beyond what the 100 could ever do. And I'm talking about, especially in mill turn, it was leaps and bounds ahead of it. Then you get into the OSP 300, and all it was just fine tuning of that 200, right? They added some things to it. And I'm sure an Okuma rep would get on here and point some different things out to me, as to why and what. But the OSP 300 was fine tuning of that 200. And I know for a fact that the OSP 300 did some stuff with the tool changes on a mill turn, on a Multis. They did some stuff with the tool changes to condense it down and make it easier for the end user. But again, the core of it was the OSP 200 moving into the OSP 300. And then they get into, oh, we've got some fancy high-speed machining and some NURBS and this and that and all kinds of other stuff, right, that they put in, and they make it better for you, if you will.
Right. So yeah, that sounds, well, first of all, reading manuals sounds awful. So I'm just going to throw that out there. I'm really glad that's not my job. I'm glad that that's your job. Yep. Speaking of writing posts being somebody's job, right? You know, I hear a lot of people asking, hey, I was an AE for a long time, and I get the question, hey, can we write our own posts? You know, can we write our own post processors? And my answer was always, if you want to, sure, but we have guys that do it every day. That's going to do it in way less time, right? And probably way more accurately. In your opinion, right, just in Craig's opinion, what percentage of shops do you think are just dealing with a post processor that's not utilizing their machine, or they're modifying it by hand? You know, something that would make something a quote unquote bad post processor. Like, what percentage of shops out there that you've seen aren't using the most utilized post processor?
Wow. Yeah, it's well over 50%. I would say it's well over 50%. Yeah. I mean, it's a lot. Like, you know, when we talk about that, we talk, like, one of the things that we always tried for, always as a post writer, you always try, don't edit the code. Like, that's the goal, right? The end user should not have to go in and touch that code. They shouldn't have to deal with it. The reality is that, well, sometimes that doesn't always happen, or you get a new part and you're kind of trying some stuff and you've never ran across this before, and you need to get in there and edit, right? But generally speaking, it shouldn't happen, right? You should be able to post out and go, basically run with it, right? Look the code, run it through, you know, a simulator or whatever, and then run with it. But the number of shops that are going, well, every time I post out, I have to change the spindle line to this, this, and this, right? Or I have to move this around to that and this and that. And that is problematic. Like, as a post writer, I look at it and I go, why? Why are we doing that? Why would we edit something that's simple every single time? That's a simple, or it should be a simple edit in the post processor. It should be something that you can correct and make it repeatable always so that you never have to edit that area again. Now, will there be another area to edit? Probably, but that particular area and the percentage of shops that are doing that every day is probably almost close to all of them, right? Like if you talk to a shop and ask a shop, do you love your post-processor? There's not a lot of shops that are going to go, yeah, I love my post-processor, right? Or,
well, you know, and to be fair, I don't know that a lot of shops even think about their post-processor, right?
They might not.
I mean, when I was, so, you know, I came out of my apprenticeship back, you know, we did my final project was inventing the wheel. So that's how long ago I did my apprenticeship. But, you know, when I first got into the shop, you know, I didn't know what a post was. Like, I didn't know how that worked. All I knew is I hit this little button on the cam system, whatever the cam system was, and I got this file that I threw onto the computer, and then that was it. And I don't know that a lot of people really think about, you know, what their post processor is, whether it's good or bad, right? So really what we're talking about here is, you know, what makes a good post processor and a bad post processor. You know, a good post processor is one that you don't have to hand edit, right? I didn't know that Haas, Craig, that like you were saying, would automatically kind of put that spindle on for you. Like there's some kind of automation in these machines. They probably don't televise it because they don't want to have people be lazy and just be like, it'll turn on itself. But
like
that level of automation is amazing.
Yeah. There's always that back checking. On Haas is really good for that, right? They've always made it so that, like, look, anybody can run this machine, you know, and it will do exactly what you want it to do. So they obviously back check certain things, you know. How well that is, I don't know. I don't own a Haas, so I don't get to run it. I just know who I've talked to and what I've found over the years of working with customers and reading manuals and working with AEs for Haas. And you know, that was the other thing. Like, I know, you know, I have a bunch of AEs for manufacturers that I reach out to when I'm in question, because even with all my years of experience of writing posts, there's always questions, always. Like, you know, you'll send something, I'll make an adjustment and I'll send it out back to the customer and I'll go, okay, try this. And he'll come back and go, it didn't work. I'm like, okay, what's it doing? Give me a video, like show me a little something, right? He'll show me, and I just don't understand. Am I missing something? You know, you bring up Okuma. Okuma's very, very finicky with their code. Like, I've had code not run because of a decimal point being missing. And it just wouldn't run. And you're like, why is it not doing this? So the logical thing is it's not making the shape because my code's wrong. No, it's because there was no decimal, you know, in the Y line, except in the Y, but the X and the Z had it, right? I mean, stupid, crazy, little weird things like that. Those things pop up and they cause problems. So
yeah, for sure. And you know, and again, I mean, tricky. I don't make money off of people getting custom post processors. I'm a big advocate of it,
right? Because
of stuff like that, right? I mean, there's so much more that your machine could probably do, right, Craig? If someone out there has, we talk about Akumas or whatever, name it. It could be a DMG, I don't know if this DMG Mori still DMG Mori, right? Maybe one of those. Or definitely. DN machines are amazing. DN machines are awesome. So it could be even a DN machine. They're so powerful, right? If someone doesn't have a good post processor, are they really getting the most out of their investment, right? So let me ask you a question. So when we talk about easy posts, you talk about, I got the core, it's just cosmetic and things like that. What would make a post processor difficult, like to do, like, that's a pretty difficult post processor? For instance, I heard Heidenheims are supposed to be pretty hard to write for. What makes it difficult?
Yeah, so the difficulty level with posting can come from the language you're writing the post in, right? So a lot of these posts, and I shouldn't say a lot, like I haven't been exposed to all the posts in the world, so I don't know. But the environment I worked in was a very archaic environment, and that environment had its own restrictions, right? You couldn't do certain things, and you had to abide by the laws within that language. And I think most posts you're dealing with that, right? There's a few out there that are using, you know, some higher level languages, Python and things like that. But for the most part, these CAM systems, they utilize a lower level language, something like BASIC, right? Which is, you know, pretty old, or something that was hashed together to create their post. And so, you know, when you talk about the difficulty level when you get in there and what's complex, I mean, you know, I always think of, I had a customer out here, and they're a big customer, and they had some very big machines. You know, they had a lot of vertical lathes and so on and so forth. And I had one customer, they were getting a new machine in, and it was a Pietro Carnegie, and he needed coolants, lots of coolants, right? He calls me up one day and he goes, Craig, I need coolants. He goes, I need this, that, and that. And I don't remember the specifics. I just remember he goes, they have 10 different pressure settings. And I'm like, what? I go, 10 different pressure settings. He goes, yes. And I need all of them. And I'm like, are you kidding me? I said, really? And he's like, yep. And I said, dude, you're a programmer, not the machinist out on the floor. Like, how are you going to be able to tell the difference from 200 PSI to 300 PSI? Like, what's that going to do for you? Right? Like, literally, as a programmer, I have no clue. Right. But I'm like, okay, fine. This guy needs this, right? It's what he needs. And that's what he said. He goes, Craig, I need this. I'm like, okay. So, dude, I go into it and I start working on it. And I'm like, oh, this is complex, right? It gets really nasty inside, and you've got to check for this and check for that, and make sure this is not on and that's not on, and blah, 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 blah. So you're back checking and double checking and triple checking. So anyway, I get this thing all done for this guy, and I must have spent, I don't know, let's just say 2 days on it, right? Not 2 days consistent, but a little here and a little there. And I get it all done. I send it over to him, and he goes, yeah. He gets back to me in like 2 days. He goes, Craig, that worked great. He goes, but you were right. I only need 3. I need low, medium, and high. I'm like, damn you. I wanted to jump through the screen, right? So, but those are the things that, you know, I mean, knowing him and knowing that company, I worked with them for a very long time. And I was actually friends with them and got to know them really well. So for me, it was like, okay, you know, I'll do it. My company at the time, we just edited the post. We didn't charge anybody, right? We didn't do an hourly. We just said, okay, that's part of it. And that was part of the deal. So, you know, we were able to kind of fix that. And
that's incredible. You know, it's funny that you say that too, how, you know, oh, the customer, I need it. Okay. You know, and we don't ask, right? Okay, here you go. And then it's like, well, we didn't really need it. And that's okay. So we had a really interesting comment in the chat. Sherry M said her grandfather worked for SkunkWorks in Lancaster from 1949 to 1982. What an amazing career, by the way. Wow, SkunkWorks too. That's a lot of secrets that guy knows. So anyway, he's a tool and die raker, and he'd be quite impressed with the progress that we've made since slide rules, right? Since 1949. Yeah. You know, I joked about going through my apprenticeship so long ago, but you know, even in our lifetime, Craig, right? You and I have seen an amazing forward progression in CNC machining, right? When you think they can't come out with something else, right? It's like they figured out every way to remove chips, right? Something else comes out. It is absolutely incredible. And I think, Craig, and I think you'll agree that this is one of the reasons it's really good for us as machinists to kind of give it up sometimes, right? To say, you know what, this new machine's out. I don't know everything, right? There's so much out there and so much that's new, right? I'm going to reach out to my reseller and find out if they know anything about this machine, because you know, this is new. And you know, you talk about reading manuals. Education is just so important. So Sherry, you know, we agree with you. And just again, in our short time in machining, Craig and I, you know, we've seen so much, and it's really impressive, and it's actually getting even better. You know, some of the things that I've seen coming out with the hybrid machines. When I say hybrid, 3D printing with CNC milling. Things like that are crazy. I can only imagine the post for that, Craig. You know, that would be something else. Yeah, for sure. Yeah, definitely. So, hey, Craig, you know, hey, thanks a lot. I really appreciate your time.
No, thank you for having me. Yeah, this is,
you know, really, and I want to come back and maybe we'll dig, now that we've kind of covered what posts are and how people can custom ones and things like that. kind of getting into posts and talking maybe another one. If people are interested, let us know. And we can get into what's that one line that always comes up in the beginning, G90, G8, you know, all that stuff. They talk about that stuff. So if you guys are interested, let us know. We can dig down into that. But I wanted to talk about, before we go, a couple live streams that we're going to have coming up. So before we sign off, we've got a few upcoming live streams that I honestly think you're really going to love, because these things sound amazing. So first off is live design, right? This upcoming Friday, it's going to be at noon Eastern Standard Time. We've got my top favorite SolidWorks features, right? Let's see if yours match theirs. That'd be amazing, right? So the guest star there is Senior AE Applications Engineer Instructor at GoE, Amanda Osmond. Amanda's a part of a team that teaches SolidWorks users on a global scale, right? So she teaches them how to use the software at varying degrees of complexity. She's going to join our team, right, to show off her favorite features and shortcuts. It's going to be great. You know, she's out there seeing this stuff, bringing that global SolidWorks user group to you guys. It's amazing. Also, later this month is our manufacturing themed episode of SolidWorks Live, right? Challenge the manufacturing status quo. This is great. This one is really going to be amazing. We're going to be taking a deeper dive into the manufacturing industry, right? We're going to learn about some amazing things happening on shop floors and even past the shop floor, right? Amazing topics in manufacturing and the way DS looks at it. This is going to be, I'm going to tune into this one because I love the messaging here. So check out SolidWorks Live. That's going to be on July 27th. It's going to be at 11 a.m. So it's an hour earlier than the last one. I said 11 a.m. Eastern time. All right. And as always, you can catch all of our SolidWorks Live content at at live.solidworks.com. Again, you can catch all of our live content at live.solidworks.com. And the SolidWorks YouTube channel, where we are right now. Yay. So please help us appease our overlords and like and subscribe, right? We got to pay the bills. I don't know where the button is. It's somewhere here, I think, like there. I'm not too sure, but it's somewhere around there. So if you like and subscribe, you'll be notified when these new episodes come out. So Craig, before we go, I just wanted to say again, thank you so much for your time. You were amazing today. And I look forward to hosting these in the future. I hope Mike is out in the field way more often, Craig. So thank you very much. Yeah, everyone, thank you so much and have a great day.
Thank you for having me. Absolutely.
All right, bye-bye.
Thank you, guys. Bye-bye.